Let's look at another concept related to derivative. So this is the definition. It's called a function f. You have some function f. Okay, it is called differentiable. Differentiable at some point a. Okay, if the derivative of the function at this point exists. All right. So if you have a function, right, you follow the definition to compute the derivative at some point a, and you find out you have some number, some finite value for that, and that is called the function is called differentiable at this point. All right. Now, it is called differentiable not just a single point, but at some interval on an open interval. Okay, from A to B. If it's differentiable at all points, at every number in the interval. Okay, so first we define this differentiable for a single point. And if the function is differentiable at all points within a certain range, and we say it's differentiable on this interval. All right, so this is some property about the function. It's a good property. And in many cases, we do want our function to have this differentiable. We want the function to be differentiable. Okay, so we have two properties about a given function. Okay, in previous section we talk about continuity. So you should remind yourself what a continuity is for a given function. Now we have differentiable. So these two are related, and it's given by this theorem. If a function f is differentiable at some point a, then this f is continuous at this point. Okay, so if the function is differentiable, it must be continuous. I will show some examples in a moment. Now, if you look at this theorem for 10 seconds, and you can realize that if f is not continuous at a, then f cannot f is not differentiable at a. Okay, so you can think about that. If f is differentiable, then it's also continuous at a. So if we have this differentiability, then we have continuity. Now, if we do not have continuity, then we don't have differentiability. All right? So it's like, you can, these two are totally equivalent. So we can take a look at some examples where, like, when we can have, a function is not differentiable, all right? Sometimes the function is not differentiable. So when a function, when is a function f not differentiable. Differentiable means there's no derivative. Okay, the derivative does not exist at some point. So what's that? There are three cases where this function is not differentiable. The first one is already given here. If f is not continuous. At this point A. If it's not continuous, it's not differentiable. So you can just draw any function that is not continuous at a given point, then it's guaranteed it's not differentiable at this point. So for example, you can make a function, right? It goes like this. Then you have a jump, then you go after that. So at this point A, right, you have a jump. So this is not continuous because you have to leave your pencil in order to go from the curve on the left to continue on the curve on the right. So it's not continuous, and that means it's not differentiable. Right? You don't have a derivative because in order to have in order for this function to be differentiable, we have the limit, right? And we don't have a limit here because there's no limit at this point A. So it's not continuous and it's not differentiable. This is one possible case. Or you can do the other one. Simply just make an open circle, right? Now at this point A, it's not continuous because you get a cut. There's a breaking point here. So there's a cut, so it's not continuous. And then not differentiable. The derivative at this point does not exist. All right? Now, the second case where a function is not differentiable will be f has a corner point. That means a sharp turn at A. Remember what the derivative is, right? It's basically the slope of the tangent line, right? You have to draw this tangent line and you look at the slope, and that's derivative. So if the slope of the tangent line exists, then we have derivative. Then we can call that function to be differentiable at this point. Now, if you have a function like this, say, okay, it moves up, then it just take a sharp turn and do this. All right. So the function is, let me draw the blue one. It's this. At this point, which is say at A, it make a like a U-turn or something, and then it go back down. Now, let's look at the derivative at this point, right? Derivative means we draw the tangent line and we look at the slope of the tangent line. Now, if you want to draw the tangent line here at A, how do we draw that, right? If you go from the left, right? If you go this way, the tangent line seems to be like this, right? It's, right? You have this increasing trend. So if you go from the left, the slope is positive because it's increasing. Now, if you keep going after A, then you have to follow this curve now, right? And this curve is going downward. That means the slope is negative. Oops. Oh. right? So what is the slope at this point? We don't know. It's not unique, right? If you look at the curve on the left, that will give you a slope which is very positive because it's you have this very sharp, very fast increase. Now, if you look at the curve on the right, you have a very fast decrease. That means the slope is negative. So we don't have a unique slope here. That means we don't have a derivative, and then this function is not differentiable at this point. All right. So this is the second case. If the function make a sharp turn, either go at the long, it's not a very smooth turn. So it could be like the function could be like that, right? This is not very sharp, but still you tend to move this way, then you tend to move that way. So they're not in the same direction. It could be very sharp, right? It could be just like, not very sharp, but still it's not that smooth like that, right? So at this point, it's not differentiable. At this point, it's not differentiable. And also at this point, it's not differentiable. Because you have to change your direction if you follow the curve. So that's the example where the function is not differentiable if you have corner point, or we call that sharp turn. The third one is if f has a vertical tangent line. Right? So at this point A, that's a case where you have a derivative that's like infinity. So for example, if you have the curve which look like that, you have a curve, right? And then at some point, it's vertical, right? Now, if you look at this point here, the slope is like this, right? It's just pointing downwards. So it's negative, but it's it's so negative. It's not a finite. The derivative is not a finite value. So for that case, the derivative actually it's negative infinity because you go just all the way down. You just shoot down like this. So it is negative infinity, and that's not a finite number. So the derivative does not exist, and this is not differentiable. So it's not differentiable at this point. Okay, because it just the derivative is so big, it's negative infinity. So these are the three cases where you do not have differentiability, and I can give you some examples. So be careful about that, right? Even though you have the formula, you cannot just say it's differentiable at all points. Let's try this one. Right, say your function, and you have a curve which goes like this, and that, and then goes like this. Right? This is a very weird function. So we have 3 points. I call that A1, A2, and A3. All right, it seems like this curve is continuous. It's differentiable at all other points except these 3, right? We have to consider these 3 points individually because they are not very traditional, right? So in the first point, A1, it's not continuous because you have this cut, right? If it's not continuous, it's not differentiable. So this is not differentiable. Now at A2, you have a jump. And jump means the function is not continuous. So if it's not continuous, it's not differentiable, right? So these 2 points, the reason they are not differentiable is they are not continuous. Okay. Now at A3, it's continuous, right? You just everything is continuous. You don't have to leave your pencil to follow the curve, but you do have a sharp turn, right? It used to be very negative, then all of a sudden it become very positive. There's no transition between the two. So this is not differentiable as well because this point is a sharp turn, or the corner point if you want. Okay? So that's something about differentiability of the function. Remember, if it's not continuous, it's not differentiable. If you get a sharp turn, it's not differentiable. If you have this vertical tangent line, right? That means the curve just go straight down, and then it's not differentiable.